Another interesting question, a long cylindrical wire carries positive charge of linear charge density, that is your linear charge density is your 2 into 10 to the power minus 8 coulomb per meter square. An electron revolves around it in a circular path under the influence of electrostatic force. Find the kinetic energy of the electron. Remember that it is independent of the radius. So here what we have to do, we have to think it that what should be the cylindrical rod is a long cylindrical rod first. Long cylindrical rod, that is your, say for example, this is a long cylindrical rod. Say this is a positively charged and having the linear charge density itna surface charge density. An electron revolves around it in a circular path under the, एक इलेक्ट्रॉन सर्कुलर पाथ में इसके चारों ओर घूम रहा है. One electron revolves around it. So our purpose is to find the kinetic energy of that electron. We know that the lambda is given. That should be, if the linear charge density is there, not the surface, it should be meter. Linear charge density 2 into 10 to the power minus 8 coulomb per meter. That should be the linear charge density. Linear. And it is given 2 into 10 to the power minus 8 coulomb per meter. And we know the electric field intensity around the charge, this charge rod, that we had already gone through lambda by 2 pi epsilon naught r. ये हमको मालूम होना चाहिए. Right? Now the force experienced by electron जो उसके चारों ओर घूम रहा है, electron due to electric field produced due to the electric field produced by wire, charged wire, that should be equal to the centripetal force. How comes the centripetal force? When any charge is revolving around it, so definitely without centripetal force it is not going to revolve. Some forces must be there to provide the necessary centripetal force. So here the force experienced by the electron, how much is the force experienced? That is the Q into E. We know Q into E is equal to mv square by r, or I am just multiplying half QE is equal to half mv square by r, because our purpose is to find the kinetic energy that is equal to half mv square. So I am just calculating it. So it is half mv square is equal to half q e into r. Now put the value of this half q का value हमको मालूम है. The value of q is your 1.6 into 10 to the power minus 19 coulomb. E is already given, lambda by 2 pi epsilon naught r into r. So this r cancel and just put the value and you will get the result. And for expedite the solution, I am using the calculator. The answer is, if you are calculating, 2.88 into 10 to the power minus 17 joule. That should be your answer. Kinetic energy. This is your kinetic energy. Another question, two parallel plate capacitors are there connected in series, 40 microfarad, and another is also the same 40 microfarad. First one is having in between the plates, it is filled with the dielectric medium having the dielectric constant K. Here air is there, nothing is there, means air. Now find the equivalent capacitance. So how we are going to solve it? We know that, say it is having the name, first one is C1, another is C2. So C1 will become K into C0. K into C0. K is given 4. C0 is your 40 microfarad. So it is 160 microfarad. And C2 is 40 microfarad. These two are connected in series. So the equivalent capacitance will be C1, C2 by C1 plus C2. So put the value 160 into 40, that's microfarad both, by C1 plus C2 means 200 microfarad. So by calculation, that is 32 microfarad is your answer. Another question, a parallel plate capacitor has plate area A. Plate area A. And plate separation is small d. The space between the plates is filled up with to a thickness S x, which is less than d, with a dielectric constant K. Calculate the capacitance of the system. This is the diagram. This is a dielectric medium, small x, and here the d, separation. So here we know that capacitance between the plates is equal to, if no medium is there, epsilon naught A by D. But here in between this, that is one dielectric medium is there, that should be in, if you are going to multiply K. How the K? We know C is equal to K C naught. That's a, so K into epsilon naught A by D. And that should be the, so here we are going to see, if we are going to mark it A, B and C. So here C is equal to K epsilon naught A by D. This is in fact the capacitance. यहाँ पर दो कैपेसिटेंस जैसा दो कैपेसिटर जैसा काम कर रहा है, एक ये डायरेक्ट्रिक वाला, एक ये एम्प्टी. सो ये जो C निकला, दैट इज बिटवीन A एंड C, A और C के बीच में डायरेक्ट्रिक मीडियम का, इसका कैपेसिटेंस K से मल्टीप्लाई कर दिए. एंड बिटवीन C एंड B, कैपेसिटेंस बिटवीन C एंड B, यहाँ पर क्या हो जाएगा, एप्सिलॉन नॉट A बाई, अब B और C के बीच में यहाँ पर ये तो एप्सिलॉन नॉट A बाई सेपरेशन, ये दोनों के बीच का सेपरेशन क्या हो जाएगा, D माइनस एक्स. एंड these two आर कनेक्टेड इन सीरीज. ऐसा लग रहा है एक एम्प्टी है, एक यहाँ पर डाइलेक्ट्रिक मीडियम, ये दोनों सीरीज में कनेक्ट है, सीरीज कॉम्बिनेशन है. तो सीरीज में C इक्विवेलेंट क्या हो जाएगा, जो रेजिस्टेंस का अपोजिट होता है, दैट शुड बी C1 C2 बाई C1 प्लस C2. सो बाई पुटिंग द वैल्यू you will get K epsilon naught A by K into D minus x minus 1. That is the C equivalent. Another interesting question, the space between the parallel plates of the parallel plate capacitor of the capacitance C is filled with 3 dielectric slabs of identical size. If K1, K2, K3 are the dielectric constant of all 3, find the new capacitance. यहाँ पर this is the diagram. K1, K2, K3. And very interestingly, the capacity is C. So the capacity of, if you are going to see it in this manner, just you tilt the copy and just to see these are the three capacitor. It works as three capacitor combined in parallel. So here the capacity of individual capacitor क्या हो जाएगा C/3. So these three are connected in parallel, so we can write it C equivalent is equal to पहला का K1 into C/3 plus K2 into C/3 plus K3 into C/3. So ultimately C/3 within bracket K1 plus K2 plus K3. That your answer.